So let's go ahead and record this. Hey Cole, how are you doing? You're probably going to be watching this, hopefully. Everybody say hi to Cole.
Hi Cole. I love you, Cole.
There you go. Hopefully he's watching this sometime. So 228:19. So what are we doing today? We are going to be translating and transforming polynomial functions, okay? So the word translating means just moving. I don't care if you guys know these fancy words, but I'm going to throw them at you anyway, so that one day when you're in college and some professor throws these terms in, you're going to say, translating just means moving. And transformation, remember like the Transformers? Transformation means to change it. Okay, that means its shape changes. It's a shape. So translating just means to move. A transformation means it's a shape change. Got it? Polynomial functions. Okay, so first of all, here's f of x, x cubed. So we're going to take this graph and we're going to move it. So one of the things that we see on this point right here, it isn't a min, it's not a max, right? But it's called an inflection point. We've talked to this before, right? This is called an inflection point. So if I'm going to move this graph, the easiest way to move this graph is to move the inflection point. Does that make sense? Yes. So we're going to move the inflection point. In this case, we're going to move it, remember the opposite, we're going to move it to the left, 2, and then down 1.
So vertex is...
Yeah. So we're going to go to 2, we're going to go right there. So that's where my new inflection point is going to go. And then we're just going to graph our x cubed. Okay? And our x cubed is, from the inflection point, if I go 1, 1, right? 2, 1, 2, 3, 4, 5, 6, 7, 8. Are you making sense? Right? 2 cubed. Negative 1, 1, and 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay, there it is. That was pretty easy, huh? You guys agree? Yeah, Daisy?
Why is there an F in front of it?
Great. It is, so here's f of x. This is our function. We're going to take our function, this function, we're going to move it back to negative 1. What is the function? X cubed. And then that makes our new function, g of x. This is our new function, g of x, because we took f and we moved it, right? Okay, let's take a look at number 2, okay? So, x to the 4th. What does that look like? Well, I don't know. I've got that right there, right? There's my x to the 4th. So let's move this one. So we're going to move it to the right 1, and then we're going to move it down 4, right? Because we always go the opposite of the inside, correct? And it's going to be half as tall. Because we're going to have what we call a vertical shrink, right? That's a vertical shrink. So let's go to the right 1, down 4, 1, 2, 3, 4, right? And we're going to go over 1, but we're not going to go up 1. We're going to go a half of that, okay? So instead of going over 1, up 1, we're going to go half of that, which would put me at a 1/2. And of course, we'd have this exact same thing over here because it's symmetrical, right? I'm going to go over 2, and normally I'd go up 16, right? Because 2 to the 4th power, normally I'd go up, right? I'm taking this graph, I'd went up 16, right? But I'm going to go half of that. So instead of going up 16, I'm just going to go up 8. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. And that's enough of it. I don't need any more of it because it's not going to fit. Okay? So I'll do it again. Saul, you ready? So from here, I'd normally go over 1, and 1 squared is 1, right? But I'm going half as tall. I normally go over 2. 2 to the 4th is 16, but I'm going to go half of 16 is 8. Okay? And of course it's symmetrical, okay? You guys ready to flip the page? All right. Okay, now write a rule. So we're not going to graph it, but write a rule. So f of x is x cubed minus 3. So it's technically this graph, but it's down here. So the graph we're looking at really looks like this, okay? I'm going to take this graph and we're going to translate it 4 units to the right. So to the right is on the inside, right? So we're going to do it on the inside opposite.
So that would be -4.
Totally right. And then we're going to shift it 2 units up. So we're going to go and add 2, right? And then vertically stretch by 3. So we're going to make it 3 times as tall, okay? So my new graph is going to be g of x equals, you ready? I'm going to stretch it by 3. I'm going to translate it 4 units to the right, so I'm going to make it an x minus 4 cubed, right? Cubed, it's still an x cubed. Minus 3, but I'm going to add 2. Okay, I'll back up and let you see what I've done, okay? So I've stretched it by 3, okay? I moved it right 4. I took the graph and brought it down 2, okay? Yes? Question? Yes, I'm going to do that. You're ahead of me. Good man, you're ahead of me. So how about g of x equals 3 times x minus 4 cubed minus 1. Now I want you to see this. This is acceptable for me, but it all depends on how you read it. Okay, now you got to be careful. I'm okay with this, and this is where it's ambiguous, and this is where I have a problem with the book, okay? So, did we stretch it before we moved it down, or did we stretch it after we moved it down?
Yes.
How do we know?
The order of operations in the text.
So, it might need to be this instead.
No, we don't have to do that.
No.
So, what also might have gotten stretched was where it started,
Yeah.
right?
Wouldn't it-
It could be this, because if I brought it down 1, but then I stretched it, does that include where I started? I personally like to believe this is what happened, but there's no way to know. The way it's worded, it might even be this one. Does that make sense? It might have been stretched. The beginning, the bottom point might have also been stretched by 3, okay? I like to believe that it got stretched up from here, okay? Hope that didn't confuse you.
No, yeah, I think I'm trying to confuse them, sir.
I'm trying not to. That's what I'm saying. I'm okay with this, all right? I'm okay with this. Yeah,
Well, it says vertically stretched. So
Right.
stretch it.
right. So when I read vertically stretched, I don't know if they mean the y-intercept is stretched also. I know. Jeremy, which one do you like better? Stretching the beginning point also?
Say read it the way.
You like this better? Yeah, me too. Okay, but we got to be careful because the book sometimes puts this, right? You and I talked about that before, haven't we? Yeah. Okay, example 4. Right rule. So horizontally stretched by 2. Now you got to be careful. This is on the inside. This is the one that kills us all, okay? It's got to be on the inside, but the opposite.
So that would be -2x.
It's going to be a 1/2.
What?
Yeah. So, and reflected over the x-axis. So I'm going to go g of x equals, you ready? A 1/2 x to the 5th, but I'm going to make it negative here, okay? And I'm going to hopefully explain a little bit better the horizontal stretch. So let me stop recording.